y'all. Today we're going to talk about magnitude of a vector. Magnitude is the size of our vector. So we're going to talk about how big the vector is. Not only do vectors have size, but they also have direction. So we can graph them either in an XY coordinate plane or even in an X, Y, and Z coordinate plane. If there's an X, Y, and Z coordinate plane, that means it's three-dimensional. But we're just going to stick to three-dimensional for today, finding the magnitude of a vector. So the magnitude of a vector is shown by two vertical bars on either side of the vector. So the notation may look like this. Two vertical bars and then your vector in the inside. Sometimes you'll see a double bar so that when we are looking at this, we don't think this is absolute value. So on occasion, you may see two double bars like such. That way you will know that, hey, we're dealing with a vector and we want to know what the magnitude of that vector is so that we don't confuse that with absolute value. So this is a formula that we need to know. So the magnitude of vector A is equal to the square root of x squared plus y squared. The magnitude of vector A is equal to the square root of x squared plus y squared. This is from the Pythagorean theorem. So a squared plus b squared equals c squared. We're trying to find the size of it, except for we're only using the x and y coordinates. So as always, let's go through and do some examples. I'll try to keep that formula in view for us so we can follow it. This is our first vector, 2, 3. The first one's x and the second one's y. So if I'm trying to find the magnitude, we do 2 squared plus 3 squared. And you either can use your calculator, Desmos, mental math. 2 times 2 is 4. 3 times 3 is 9. I add that together, gives us the square root of 13. So this is x and this is y. I substituted those into the formula with our square plus, and then we take the square root of it. 2 squared, 3 squared, add together, and this is 13. 13 is a prime number. I can't do my factor trees and break that down anymore, so we'll leave it as the square root of 13. Number 2. Still using that same formula, negative 6 squared plus 3 squared. I do like to put what I'm substituting in parentheses, just so that you know that's all inclusive there. And you also should know that anytime you square something, you're going to get a positive number back. So if for some reason you substitute this in and you get negative 36 back out, hopefully that'll stand out to you as being incorrect, because we should get a positive 36. So negative 6 times negative 6, as I just said, is positive 36. 3 times 3 is 9. I add that together, and we get 45. So I went through, I followed the formula, added together, and we get 45. So each of these numbers at this step should be positive, because we can't take the square root of a negative number. It would be no solution. Now, 13 was a prime number. I can't break that down anymore, but I can break 45 down. So we want to simplify all the way down. So 45 is 9 and 5. 9 is 3 and 3. Pairs go on the outside. Everything else goes on the inside. So my final, most simplified answer, the magnitude of this vector is 3 times the square root of 5. So this is a skill from a previous math class. So just a reminder here, you break it all the way down to prime numbers. We do factor trees. 9 is 3 and 3. That's 5. You're looking for pairs. Pairs go on the outside. Everything else goes on the inside. Again, pairs go on the outside. Everything else goes on the inside. And the last one that we can take a look at, we're going to find the magnitude of negative 4 and negative 2. Both of these are negative. And that's all right. But we know our final answer, once we add these together, should be positive. So negative 4 times a negative 4 is 16. Negative 2 squared is 4. I add this together and we get 20. So even though I have two negatives in here, your answers should always be positive, because regardless of if you have a positive or a negative, when you're squaring it, you get a positive back. Now 20 is not prime, so we can do our thing and break that down. 20 is 10 and 2, or 5 and 4, whichever numbers you want to start with. And 4 is 2 and 2. Pairs go on the outside. Everything else goes on the inside. So our final answer is 2 times the square root of 5. So let's take a look at all three of those together. We're finding the magnitude of our vectors. We use the formula square root of x squared plus y squared. If it's a number that can be broken down, you do need to do your factor trees and break it down. But if not, you can just leave it, for example, as a prime number here, you can just leave it like that.